The first technique is process hazard checklist. Okay, you have your word checklist here. Okay, checklist. So this is the checklist. So what is process hazard checklist actually? Okay, so checklist is some example is when you are try to fix your car or you make some services for your car maintenance. Okay, so this is classic automobile checklist. Okay, this is classic automobile checklist, but the engine beside is not a classic. Okay, this is Nissan GTR engine. Okay, so for the checklist, classic automobile checklist, okay, you have your engine oil, air pressure in tires, and so on. So why we call it as a checklist? Okay, because you can tick it. Okay, you can tick all the things or the item that already been checked and approved. Okay, so maybe okay for example, okay, checklist. How about engine oil? Okay, already changed. Tire pressure okay. Fluid level in radiator already checked. Highlights and taillights okay. Exhaust system for leaking okay. You have new brake system okay. So how about the fuel? Okay, so this is all about checklist. Okay, so this is for car maintenance. Okay, later on we will see what is the checklist for a chemical plant. Okay, so checklist for chemical process can be detailed, involving hundreds or even thousands of items. So for example, this CSTR, okay, this item or this uh, apparatus already contain about hundreds of items for their checklist. Okay, can you imagine for the whole plant how many your items for your checklist, right? Maybe if you want to check the lights for the whole plant also involve thousands of items. How about all the equipments in here? Okay, so maybe checklist is not suitable for the whole plant. Okay, as you can see, okay, process hazard checklist. It should have a list of possible problems and area to be checked. Okay, it reminds the reviewer the potential of the problem areas. Where are the problematic area? So this checklist actually can be used during the process design or before you start your operation at the beginning of your plant process. Okay, so during the process design and then just before your plant operate. Okay, so basically it's only checklist. Is it already okay with your design or with your operation? Okay, so the best result is obtained if hazard identification is performed together with risk assessment, just like what we see previously. Okay, high rate procedures, high hazard identification combined with risk assessment and also risk control. Okay, so the justification on why hazard identification is very good to be combined with risk assessment and also risk control. Okay, this is because this could prevent gold plated. Okay, to prevent the gold plated scenario, your hazard identification technique should be performed during your process design. Okay, during your process design before you start your operation. Okay, because when you prevent gold plated, in other words, you you try to avoid from implementing unnecessary or expensive safety equipment and procedures. Okay, that's what we call as a gold-plated scenario. Okay, for example, you already design your reactor. However, you don't make your checklist or your hazard identification procedures during your design. Okay, then after you already make a commission for your reactor, the reactor already been built, you will see that, oh no, this reactor is too low for the process, or maybe, oh, if the reactor is at the ground level, it will become hazardous to the surrounding. Okay, so you see, if you're not making hazard identification at the early or during your process design, and after you finalize or you already built your reactor, you already commission it, okay, then you realize, oh, this is hazardous to the surrounding. So now is the gold-plated scenario, because you need extra work, you need extra equipment and procedures just to prevent this reactor being hazardous to the surrounding. You need to make a lifting or skirting for the reactor and whatnot. Okay, so this unnecessary or expensive equipment and procedures is a gold-plated scenario. Okay, so to prevent this scenario, we try to make hazard identification at the early step, okay, during the process design or before the process operation. Okay, so the first one, maybe you can start with simple hazard checklist, okay, before you're going further. Okay, because all these hazard identification techniques can be combined. Okay, it can be combined to make a very good hazard identification or hazard procedures. Okay, so the first one is this hazard checklist. Okay, we will see where the example of checklist. Okay, so a typical checklist can cover maybe the general layout of your plant and then the buildings process. So under this process area or the piping area, there could be another sub listing of the condition of the piping, the condition of equipment, and so on. Okay, you have your instrument, electrical, safety equipment. How about your fire extinguisher? About your all your MSDS file for your chemicals. About your raw materials, your chemicals, where you put it, is it safe? Okay, there are sub items that can be listed below this checklist. Okay, this is the example of typical process design safety checklist. Okay, as you can see here, you have this column. Okay, just to make a tick, yes, no, and further, or you need advanced study. Okay, so you have your general layout, you have buildings, process, and so on. So this is the sub item for the checklist. So building, is it adequate ladders, stairways, and escapeways? You make your surveys, you make your check. Okay, so if yes, just complete. If not, your does not apply. Okay, you think on does not apply. So at the end of your checklist analysis, you know that where you can take more, you can take further action just to prevent the incident from occur. Okay, or maybe further study required. You need more thorough analysis. Okay, so this is the example of safety checklist. Okay, this example has been taken from Chemical Process Safety Fundamentals with Application from Crow and Rover, your textbook. Okay, you can see the example in your textbook. Okay, this is another one. Okay, so right now there are also software, okay, for your checklist. So you can develop a new checklist for each of your equipment. Okay, so this is an example for the checklist that have been developed for chemical plant. Okay, so the checklist design depend on your intention. Okay, what is your intention for initial process design? Okay, or for a process change? Maybe you can also have your checklist for some specific piece of equipment only. Okay, just for heat exchanger, for the reactor only, not a thorough overall plan. Okay, so your checklist can be covered as a hazard identification procedures. However, it should not be used as a replacement for a more complete hazard procedure. Okay, because this uh, this checklist is not very complete. Okay, it's not detailed to make as a replacement for hazard procedure. It should come with a combination with another hazard procedure. Okay, so later on we will look the second procedures or the second techniques, which is hazard surveys.